Hey. Okay, so I actually have the fatal combination of not just being the talk before lunch, but also having a 40-minute talk in a 30-minute slot. So I did two things. One is that I don't really drink coffee normally, so I had 2 cups right before this. So we're going to do that 40 minutes in like 25. And the second is, if this talk sucks, you can just leave early and get a jump on lunch because there's food trucks already outside. So either way, you win. Super brief background, and I've never been able to be heckled in real time on Twitter. I am super excited about this. I've just been able to read insults in real time about my talk right there. Brief background, I started out in offensive security, so I started out in pen testing, security consulting. If you're familiar with companies like NCC Group or ISEC Partners, which was the main US firm that they acquired, started out there, moved over to Etsy, where I was the first CISO. And I've got to say, what I love about being at a DevOps event is I don't have to explain why a Yarn website was good at computers. People actually know what Etsy is and everything there. So I built and ran the security group at Etsy. And then about 3 years ago, myself and my 2 other co-founders from Etsy left to spin out Signal Sciences, where we took a bunch of the lessons learned, turned it into a product that now you can drop in to get protection and defense for your web applications or your APIs or anything that you really expose there at the web application layer. That's not what this talk is about. No one needs to hear from yet another vendor. So let's actually jump into what this is. This talk is what I wish I could have given myself on day 1 of starting my job. It's really historically we've built software in kind of the waterfall methodology, and what changes along the way as we move to agile, to DevOps, to CI/CD, to whatever kind of placeholder term we want to use there. This was super jarring for me in terms of the jump that I made, because actually my last project when I was doing security consulting was at a major US healthcare company. They deployed to production once every 18 months. And I left there on a Friday, and because I'm an idiot and took no time off, I started at Etsy on a Monday. And on day 1, they said, okay, we deploy to production at the time 20 times a day. Figure out security. Go. I'm like, okay, well, I'm going to need a lot of whiskey and probably some tears, and we'll do this. And so this is really the collection of lessons learned out of that. What failed spectacularly? How do we adapt the way that we have thought about security controls and adapt them to actually enable this? So I'm going to give you the conclusion right up front, which is that security shifts from fundamentally being this gatekeeper and this kind of outsourced function to security's prime role is now focused on enabling teams to be secure by default. This is a really fundamental shift for security, and it changes a lot of things we do both on the technical side and on the cultural side. So what has changed? A lot of times I'm speaking to security audiences, and they really, I think they understand much less than this audience what has actually changed here. So I won't belabor the points on, what DevOps is and all the radical change of that. But I think from a security perspective, there's kind of 2 big high-level changes. The first is that change happens orders of magnitude faster now. It's not just an order, it's orders of magnitude faster. That deployments that would go from once every 12 or 18 months now go down to every month or every week or every day. And that means from a security perspective, we had kind of many injection points into the process. Right? If it takes 18 months to build and release software, we've got a long time to go talk to development teams, talk to DevOps teams, involve security in the process. If code is going out a few hours after it was written, the number of injection points drops drastically, and it functionally drops to basically 0. You have to change the way you think about it. And the second is this decentralized ownership of deployment. It used to be, a development team would write code, it would go to over the wall to a QA group, it'd go over the wall to a security group, it'd go to a SysOps group, back to a development group to make some changes, back through the process, eventually up into staging and pre-prod and prod and everything like that. Now, one of the actual beauties of this kind of rise of DevOps is you have the means to write code and deploy it to production instantaneously yourself. Now, that doesn't mean that those functions go away. They're making a good jump on the food trucks already. Smart move. I promise I won't name and shame everybody who leaves. Don't worry, it's okay. So the important point is that those functions don't go away, right? We don't stop doing testing. We don't stop working on production infrastructure. It just means that the way that we do those functions actually changes. So there's really, from a security perspective, there's two sides to the shift. There's how do we change the technical controls, which is this talk. And then I did another one previously on how do we change the culture around security. And that's actually the slides that you see up there. If you're interested in that, just send me a note. I'll send you the more updated deck than what I've forgotten and posted up on SlideShare. So for security, this means that security is no longer actually outsourced to, right? Effective modern security is not about throwing something over the fence to security and they magically secure it and then it comes back and goes to prod. The number one goal of a modern security team, or even if you don't have a security team, whoever is responsible for security, the number one goal of any sort of security resource in an organization is making development teams and DevOps teams security self-sufficient. That's the number one goal. It's really this existential, in a lot of ways, it's actually an existential crisis for security right now, because if security keeps functioning as this blocker and this gatekeeper and this thing that slows the process down and says no, it's just going to be routed around. And that does not end well for security teams, or anybody really. But security only becomes successful, it can actually bake into that development and that DevOps process. So I'll do a highly technical diagram of how most security organizations are actually faring in this world. You have the security train plowing into the development car and the DevOps car while proclaiming safety begins with you. It's magical. So what are the technical controls that we've typically done from a security perspective for securing our applications? Everyone does these slightly differently, but these primitives are really the same in any, from a high enough level, the same in any organization, right? We do training, we do threat modeling, design review, static analysis, pen testing, that sort of stuff. So which need to adapt the most? Now, this is not to say that those others go away or that they don't change. This is merely a function of we only have so much time during this talk. So the ones in bold are the ones that I'm actually going to speak about, static analysis, dynamic scanning. But again, those other ones don't go away, right? They change as well. So first up, static analysis. When I gave a preview version of this talk, I had a different thing up here, and someone came up to me afterwards and said, you know, the record number of pages I've seen in a static analysis report was 10,000 pages, actually. And so I'm curious if anyone has ever actually seen one longer. I know I'm going to get one day if someone's like, oh yeah, I've seen a 15,000 page report. I'm curious if anyone has seen something longer than 10,000 pages. Okay, no Fortify users in the house, apparently. So traditionally, this has been done as a super heavyweight process, right? We go buy some super expensive static analysis tool, we turn that on, and it's run incredibly heavyweight and top down, right? It says, go search for every bug you can find, and what comes back is 10,000 pages. Oh, now I've got to compete with fries too. Seriously? That's not even, I want to go outside now. Thank you for at least a picture of the deck, yeah. That's tough, all right. So it's traditionally done as this heavyweight process, right, where we turn it on, it runs for everything, we get this massive report out of that, 99% of which is false positives. And then what happens in a bunch of organizations is the security team, forwards that email off to the development team or the DevOps team and says, hey, here's a report that we just ran, it's your problem now. And then the development team says the rightful thing, which is set up a mail filter. If there's any email from security and it contains an attachment, just send it to spam, because it's all false positives. Turns out that doesn't do anybody any good. And then you end up spending a lot of time on configuration and tuning, right? You spend 16 months, 18 months trying to tune this incredibly complex system down to get real results out of it. The sad thing is that those issues were actually acceptable-ish in a waterfall world, because if we release every 18 months and it takes us 16 months to tune our static analysis, all right, we basically missed one release cycle as part of it, but we'll get to the next one-ish. So how do we adapt this? And this is what I'm going to do for each of these, kind of give how we've used it and then how do we adapt it. To do effective static analysis, now you start from bottoms up. right? You don't go this top-down, turn on this big, heavyweight tool, and then try to figure it out over time. You start bottoms up and you say, okay, what are very specific vulnerability classes that we care about that we can start with the simplest ones and go up from there? So I'll give you the methodology and then an example. But from the beginning, you say, okay, let's turn it on for one vulnerability class. Okay, now we've kind of tuned out the false positives from that. People can actually, development teams, DevOps teams can self-serve. They can consume this data themselves. And even more importantly is what you're also proving along the way, which is that this is showing that a traditionally heavyweight, super slow security control can actually keep up with this sort of pace, of this DevOps sort of pace, right? You're showing that ultimately, if static analysis is going to be successful in your organization, it needs to be able to run on every code commit, right? It needs to be fast, and you need to be able to consume the results. So to give you an example of that, rather than picking all of these different web vulnerability classes, right, at cross-site scripting and SQL injection and command execution and directory traversal and all these things, start with some of the simplest ones. I like command execution. I've seen that people starting with that very effectively, because no matter what your tech stack is, there's really only a half dozen ways to actually introduce command execution vulns. So it's typically second food picture. Damn it. There's typically only a couple ways to introduce it. Beer now too, God. Exactly. Okay, and conclusion. Good, we're good to go. So the focus is, again, not only on findings, but demonstrating that this can actually be run fast enough, right? That this can really introduce value to the organization, something that was old and slow and you would think would not make the jump to DevOps. Actually, if we adapt that security control, it really can, and it really can provide value. I'm going to give you two other examples of static analysis of how we can kind of turn the problem on its head and actually get some really cool results out of that. So one is identifying when certain primitives in your code base should initiate a conversation with security, with your DevOps lead, with your tech lead or chief architect or anything like that. Because they're not, the use of these things isn't bad. They just indicate that, oh, something kind of interesting is happening here. Let's have a conversation. So the way in which we used to do kind of policies around, take hashing or encryption, for example, is we'd set a policy in our like CI tools or any sort of unit testing or any sort of process that we had there that says, oh, if something like MD5 shows up, that's bad, that's old and weak, so use SHA-256 or something like that. The problem is that gets you really good at people following a blind policy, but not why, and it doesn't get into what are they actually trying to protect. So what's actually much more compelling and much more interesting, and you can do this with grep, you don't need any sort of fancy tool, is to be able to say, hey, if something around hashing or encryption or file system operation shows up in the code base, use that to set off a flag to some of your senior technical leadership or your security team or anything like that, and use that to drive a conversation with the team introducing that. So I can't tell you how useful this has been, because you'll see something show up like a use of SHA-256, and it's like, oh, on paper, that's really good. And we went and talked to that team, like, hey, what are you actually trying to protect? And like, oh, this and this. I'm like, oh, actually, you don't need to use hashing at all. You can make use of this other service that we built. Like, it's actually faster. You don't have to deal with key management. And you can actually get to the root of what they're trying to protect and actually build much stronger protections and make things easier for those teams at once. Where if you just had a policy that said, oh, they use SHA-256, thumbs up, you never get to have that conversation. The second one is proactive alerting around knowing when both sensitive and rarely modified portions of the code base are actually being changed. The old way that security would tend to do this is say, hey, there's certain parts of the code base that you're not allowed to touch without triple sign-off and 18 different forms and everything like that. It might be like your session management or your encryption wrappers or authorization primitives like role-based access control or anything like that. What you want is security controls like that end up causing more harm than they actually help in a lot of cases. Because what happens when you're in that middle of that outage at 3 a.m. and you need to change that file, and now security is saying, no, 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 you need to get sign off, and you're like, listen, the site is down, everyone is in the room, I have sign off, trust me. But what's interesting here is what you can do, the way you turn this problem on its head, is you don't block on this sort of stuff. The way you do it effectively is you say at at code commit time, depending on whatever your system is, you say, when someone's trying to introduce a change to a sensitive part of the system like this, let them know right up front and say, this is going to notify these 4 super senior people in the organization. What this protects against is the intern making changes to the wrong file is going to back that out super quick and be like, no, you don't need to page the CTO, totally fine. Turns out I don't need to make that white space change in our session management stuff at 3 a.m. But for your senior SRE folks who are in the middle of an outage, and they can say, yeah, no problem, all those people are in a room with me right now, we're trying to fix this, security doesn't get in the way. You still get that same coverage, but you're not introducing blocking. So that's static analysis. Moving on to dynamic scanning. This meme has no relation to dynamic scanning. If you can find a meme for dynamic security scanning, you are a better speaker than I can. I spent an embarrassingly long time to end up with just this one. Anyway. So we used to do dynamic scanning as kind of a baseline means of discovering vulnerabilities, right? We'd point a scanner at our app, and we'd basically say, hey, if a scanner can find a vulnerability, we should probably fix it. Occasionally, you'd even see this stuff misused as a substitute for pen testing. That's its own set of problems, but we don't have time on that today. So how do we actually adapt this? Dynamic scanning actually changes pretty significantly, and that's why I only have 2 slides on this one, is that the way that we used to build applications is very different from the way you see modern applications being built, right? They used to be very linear, page 1, page 2, page 3. Dynamic scanners could kind of crawl those and figure things out and add some value there. Modern applications, right, you end up with a bunch of tons of client-side code. You have entirely single-page applications. All this fundamental change in application architecture. The scanners haven't fundamentally changed their architectures. They, more often than not, and I'm not saying they're useless, but I'm saying that more often than not, we all have too many projects to do, and there's too little bang for the buck. Like, the amount of effort you have to put in to get value out of kind of a legacy scanner of covering your app is generally not worth it. But the good news is you can actually adapt them for 2 super cheap and effective ways. One is ensuring that your security policies are actually being enforced. So let's say you've set a policy that says, hey, this site, we only ever want to serve it over TLS. So what you can do is you can have a scanner that crawls a site, stays within that domain, and just alert if you ever see a part of the site get served over HTTP, because as we all know, weird corner cases happen all the time, right? Just because we've set that policy doesn't actually mean that it's actually being enforced in every corner case. So we can say things like, okay, TLS is everywhere. We can say things like, let me know if part of the application ever doesn't serve up an HTTP header for security, like content security policy or X-frame options or anything like that. And the second is as a super cheap and effective extra control as a regression test. So let's say we have a vulnerability like a cross-site scripting issue in our search box, right? The most kind of classic XSS. We'll fix that issue, we'll add a unit test around it, but a cheap and effective way of making sure that our unit tests weren't broken in that space and we've actually regressed the issue back into production is have a scanner go hit that search box with an XSS payload as part of your CI/CD pipeline, or once an hour or once a day, and just have a really, because it already knows about that vulnerability, it's very cheap and easy to actually just tell if anything else shows up. Okay, security visibility. Honest status pages, if you don't follow, is one of the best sarcastic Twitter things I've ever seen. It is so painfully accurate. You'll laugh, you'll cry, it'll be great. So security visibility, how we've had it in the past. Spoiler, we basically haven't. That's kind of the key, is that we've basically had all of these isolated silos of data. We might have logs that your DevOps team has access to. We might have customer service reports like, hey, I'm getting this weird SSL error on your page. That stays with your customer support organization. It never actually escalates out. We might have outages that page like certain development folks or certain DevOps engineers. But each source of information was generally isolated. I mean, think about the relevant development data and operations data that we had before the rise of DevOps. It was totally isolated between these different groups. So what do we need to do? I mean, at this point, this is the most cliched statement. You probably heard this 50 million times just today alone of like breaking down silos. But it actually is true, even though it's cliche, right? What we need to do for security visibility is break down these silos of data that exist in the organization between different teams and bring them together so that everyone has the context. This isn't a new idea. Security loves to think that it's special and that it has to go reinvent the wheel every time. It's not. Like, take the lessons learned from the rest of the DevOps movement and apply this to security. Because I'll give you a practical example, which is take this graph, right? 500 error, just standard errors in your application. What's fascinating is if you go ask different groups in your organization what this graph implies, you will get wildly different answers, right? If you ask your development team, like, oh yeah, we let the intern push code to prod that day and then we backed out the change, it's fine. If you ask your DevOps team, it's like, that's the third time this week I've been paged. Like, when will it end? If you ask your security team, they'll be like, is that someone actually discovering an issue and starting to trigger errors in the application as they're figuring out what their payload needs to look like? And then you go ask your attacker and they're like, oh yeah, that was me discovering vulns and actually figuring out what it needs to look like. So what you want to start thinking about is, how do we bring this bit of security data together with operational data, together with development data in a way where everyone can have the context that they need to start to look at this data together and say, oh, why is someone attacking us at the same time that we're actually seeing errors in the application? Maybe that wasn't a bad code change. Maybe someone's actually being successful at attacking us right now. Right? Bringing this visibility together and in a way that can be consumed by the entire organization, that's what's key. Okay, second to last section. I looked it up. Office Space is 18 years old now. So first of all, I don't feel bad actually using this as a meme anymore. And B, I feel incredibly old. So feedback. Typically, we've done feedback as pen tests, right? And we all typically do pen tests as like, okay, let's do our annual pen test. Like, let's get coverage there. Unfortunately, that only really tells us, do I have bugs? And the answer is yes. We all have bugs. Everyone knows that we all have bugs. But just like static analysis, when applications were only released once every year and a half, that was kind of real time enough if we had a pen test once a year. How does this change? Bounties. Bounties are what change it really well. Has everyone heard of bug bounties? Does anyone actually have like a bug bounty for their organization? Curious. Awesome. Okay. So bug bounties are really cool. We lived through, it was like Google and Facebook and a couple others and us that had one at the time, which was 2 weeks of my life I will never get back or get any sleep during. Bug bounties are really cool, and I really recommend them. And now there are really cool services like HackerOne and BugCrowd and all these that can help with so much of the logistic stuff that ate up tons of our time when we just kind of YOLO'd and launched one on our own. What's cool about bounties and why I, even coming from the pen test world way back when, why I like them so much is because they complement pen tests really well. The things that pen tests are not good at, bounties are good at, and the things that bounties typically aren't good at, pen tests are good at. So with your pen tests, you typically do it once a year, and you'd be stuck with this really bad choice, which is, do I tell my pen test team to really go broad and try to get coverage, but knowing that they're going to be really shallow, or do I ask my pen test team to focus on one particular spot and try to get deep coverage on that, but ignore everything else? The cool thing is, bounties are really good at broad, continuous feedback. Because they're ongoing all the time, you can get there are ways to try to make them deep, but in general, they're very good for broad coverage. And then that frees you up to do your pen tests very focused and very deep on certain areas. So you get the best of both worlds with the two of them. Okay, lots of security people take themselves very seriously and talk about being a thought leader. So I instead will refer to myself as thought leader Hosen, which let's not get too serious here. But kind of in closing, what are some thoughts that I've seen from modern organizations defending their applications really in a very effective way? To boil it down, the hallmark of a modern application security program and just modern ways of defending your application is the combination of getting that continuous visibility and that continuous feedback. So you have a feedback loop so you can refine your process over time. To think about it another way through the attack-driven defense perspective, it's that at the end of the day, we have to be successful against real attackers. So if we want to be successful against them, we have to be able to answer the question, how do I know when they are being successful against me? Right now, the answer is mostly, I get a call from the Wall Street Journal for comment because there was a massive data breach from my organization. And what do I want to say on the record? That's not good, right? We can be doing better. And so the three real pillars of how to think about this through and why if we approach it in this way, we can actually win for the first time, which is awesome. The first is that getting that ability to detect attackers as early as possible in the attack chain, right? Right now, when we only get told by an outside news organization that we've been breached, that's not good. We're not detecting people early enough. We want to be able to detect them earlier and earlier in the attack chain because attackers have processes as well, right? They don't just show up and one day get all of your user data. They've got a whole, what's called the attack chain that they go through. They have to go through kind of reconnaissance and then vulnerability discovery and then exploitation, command and control, lateral movement, and then eventually exfiltration of data. You want to be thinking about that in the reverse and say, okay, from the final stage, how do I get visibility over that? So I detect it there. Okay, working back, how do I detect it at this stage? How do I detect it at this stage? How do I detect it at this stage? So you're planning for each stage to actually fail at some point along the way, but the coverage across all of them is what really gives you the visibility so that you can detect an attacker at some point before it's all over. The second is thinking about visibility and feedback. It's awesome because it gives you the ability to continuously test and refine your triage and response, right? Think about it in the sense of running kind of game days for operational issues or anything like that. Think about if the only time we ever tested our operational response was when we had a complete site outage. Like, you're going to be in trouble then because no one knows who to talk to. No one knows where the sources of information are. Like, how do we triage? How do we respond? Security is the exact same way, right? You want to take issues that get discovered, whether they get discovered internally, whether it's bug bounty, whether it's pen test, treat that as if that had been a live attack and say, okay, who would I talk to, right? Who would I get in a room? What sources of data would we look at? What sources of data do we not have right now? And start to treat that as your ability to triage and respond, and then also treat that as the ability to do incident response. It's called DFIR or security operations or anything there. Because what you'll learn the first couple times you do that is you start asking yourself a few questions that you really don't like the answer to. You'll say, okay, let's treat this as if it was real. Great. Let's say it came in from a bug bounty, right? And it's a totally benign researcher who had really good intentions. You can say, okay, what if they actually didn't have good intentions? Did they find anything else that they're not telling us about? Did somebody else find this 6 months ago and has been exploiting it? And you learn very quickly that you have almost no capability to answer any of those questions. You think about, okay, was this actually like exploited by somebody else or anything there? I'll tell you one of the scariest ones I ever had in my AppSec career, which is we had been doing this for a while. We'd invested a bunch in getting that sort of visibility, empowering DevOps from a security perspective. And we had one where we watched an attacker discover a vulnerability. And we knew that it wasn't an automated thing. Like, we were watching them clearly do it by hand. They discovered a vulnerability. They figured out a working exploit payload for it. And then they went away. And they never reported it to us, and they didn't actually go exploit it against real users. And you're like, okay, that is terrifying because you're saving that up for later when it's going to cause even more damage. So be it thinking about those questions, because we'd asked ourselves those questions on previous issues and had terrible answers for them and started to invest in it, it got us to that stage. And so second to last slide, security is usually all doom and gloom, but I want to leave you on a good note of where we can actually get to and a good case study of this, which was a case we had at Etsy where an attacker who turned out to be a bug bounty researcher who was awesome, discovered a vulnerability. This was different than the previous one. They discovered a vulnerability, and we were able to detect that. We detected it, and we actually pushed a fix for it before they reported the issue. So they discovered a vulnerability, they figured out an exploit, and then a couple hours later, they came back and tried the exploit again as part of their write-up that they were going to send to us, and it wasn't working anymore. And so they wrote in, and they actually published the full thing up on that Reddit thread if you want to. It's a really cool write-up because you get both sides of it. But they wrote in, they're like, hey, so I noticed this issue is not working anymore. I've been testing from my home IP address, and I promise I'm a benign researcher, and your legal department doesn't want to sue me or anything, right? Like, we're good to go? And we're like, yeah, actually, it's totally fine. Like, don't worry about it. Check your Etsy account. We'd actually sent you a message when you first started just saying, hi, we see you. Awesome. And so we end up having this fantastic back and forth interaction. And the real positivity of this, and why on day one, right, I've been a security person my entire career. Change typically frightens security people. And this is why day one of my role at Etsy, and they're like, we deploy to prod 20 times a day. I'm like, well, that's unsecurable. Like, that's, all right, I guess I'll hang out here for a year or something before I get fired. I don't know. But why I went from there to actually drinking and standing on stage and dispensing the Kool-Aid of why DevOps actually makes you more secure is this. It's for the first time we actually have the ability to react, right? Every method of software development is going to have vulnerabilities in it, every one of them. But as we move towards agile, towards development, towards DevOps, towards CI/CD, we have the ability to actually react for the first time, and we can beat our attackers for the first time. And so that's why I actually think this is a net positive for security. And when you hear people saying, oh, we can't do DevOps in our organization because security, incorrect. It actually makes us more secure. So the end is near. If I can leave you with one thought, it's that the thesis of modern application security, it used to be, let's do all of these heavyweight controls to try to find all of the bugs before they go to production. Which isn't wrong, it's just impossible, right? You want to be finding as many bugs before production as you can, obviously. But the real hallmark of a modern approach and kind of a DevOps approach to defending your applications is focusing on obtaining visibility, obtaining continuous feedback, and using that to make your development teams and your DevOps teams self-sufficient. So thank you for coming and sticking through the fries and the beer.